All right, we skipped unit 7.3. We don't do that. So don't worry, you didn't miss it. We're on to 7.4, remainder and factor theorems. So the remainder theorem written out is, and you have this typed out mostly on your paper, unless you're taking notes without your note fill-in. If a polynomial f of x, so we're just defining our polynomial, is divided by x minus a, which is a factor, the remainder is the solution. The remainder, though, the way we write this, is f of a. Okay? And then it says, in the box, the dividend equals the quotient times the divisor plus the remainder. So we add the remainder in as our final answer. Let me show you how this actually works. Okay, that's the complicated mathematical way, but let's look at some examples. We're going to use synthetic division to find a remainder. And that remainder is our solution to the problem. Okay, we're going to use synthetic division to evaluate a function. So it's another way to find the solution. Besides just plugging it in like we did back on 7.1, we could just plug it into the and then go from there. We can use synthetic division to find the solution because the remainder will be the solution. Now remember, when we're doing synthetic division, always use placeholders. And I'll show you what I mean here. I think most of you will remember this. We've done synthetic division before. Most of you didn't find it overly complicated. Okay, so number one is f of x equals 3x to the fourth minus 2x to the third minus 2, and it wants us to find f of 4. Now again, we could just plug that 4 in like we did before. We use mathematical blanks, we use our calculator, but you can also use synthetic division, and this is how you do it. Now in this case, we don't change the sign because this is the solution. This is what we're trying to figure out. So we're going to put 4 in our little box. If you remember, our little box goes over here. And then the coefficients of each of the coefficients from each of the x's all the way down to the constant, and put placeholders in if we're missing. So we have an x to the fourth, and its coefficient is 3. We have an x to the third, -2 is its coefficient. We do not have an x squared. If we don't have an x squared, we put a placeholder. We also don't have just a plain old x to the first. So we need 2 placeholders, and then our constant goes on the end. So hopefully remember this. We draw a line. First step is the one a lot of people forget, is just to bring down. The first number is just brought down. Then we multiply what's in the box by what we brought down, and we write it under the next one. Okay, and we always add here. And so this will give us 10. 4 times 10 is 40. That goes here. We add it. That's 40. 4 times 40 is 160. That goes there. I know we're getting high. I did these already with the calculator. 160. Now remember, this is where our remainder is going to be on this side of that line. That last number is going to be our remainder, and that remainder is the solution to this problem. When we evaluate it for 4. 4 times 160 is 640. 640 minus 2 is 638. So there's the answer. If we were to plug in 4 into that equation, we'd get 638. And so we could actually say an ordered pair is 4, 638. That's our solution. Okay? F of 4, another way to do it would be f of 4 equals 638. Okay? And that's another use for synthetic division. It's kind of cool. I like it. I like synthetic division. Okay, let's look at our factor theorem. A factor theorem, and this is where we're headed for all of this. Let me spell it right. If x minus a is a factor of the polynomial f of x, this is true if and only if, I love if and only if, f of a equals 0. In other words, the remainder, the solution if we evaluate for that number, is 0. So if the remainder is 0, it's a factor of that polynomial. Let's do this for number 2. Number 2, we have to prove or show that x minus 3 is a factor of x to the third plus 4x squared minus 15x minus 18. Now this is where you've got to be careful. X to the third is the factor, so we're saying a solution to this is positive 3. Zero product property, we'd add 3 to both sides. That's why it's 3 and not negative 3. Okay? Now let's write down our coefficients. Our coefficients are 1, because that's what's in front of my x to the third is a 1. So it's 1, that's x to the third. 4 is x squared. Negative 15 is on our plain old x. And then negative 18. There's no need for placeholders in this problem. If this is truly a factor, then we should get 0 as our remainder. So let's do that. Bring down our 1. 3 times 1 is 3. That's 7. 3 times 7 is 21. And again, we're adding these every time. Negative 15 and 21 is 6. And then 3 times 18 is positive 18. There we go. Now what this gives us is it's called a depressed polynomial. We've depressed it by 1 degree. We've taken care of 1 degree. So we've said one of the factors is x minus 3. If we factor that out, the polynomial we're left with, now watch what I do. I've depressed it by 1. It was originally x to the third, so now it's going to be an x squared, and these are our coefficients. Okay? So it's going to be 1x squared. I don't like that one. Why is it writing like that all of a sudden? It wasn't a second ago. 1x squared plus 7x plus 6. How did I know to go to x squared? Because I already factored out one of the x's from the x to the third polynomial. So that means we depressed 1 and came x squared. Well, what? Then we go down. We just go down. 2, 1, 0. I'm talking about exponents. Now, if we wanted to continue this even further, I could factor this polynomial. And this polynomial actually factors to x plus 6 and x plus 1. Now we would know that this cross, if I did the zero product property, I now know all the places it crosses the x-axis. And we're going to use depressed polynomials a lot. Let's do 2 more examples of this. Number 3. It gives you a volume v of x equals x to the third plus 7x squared plus 2x minus 40. And if you look on the cube, it gives one of the dimensions or one of the factors. So one of the factors on the cube is x minus 2. So that means one of the solutions, one of the places it crosses the x-axis is at positive 2. Remember, we have to solve it. Zero product property says it's at positive 2. If it's a factor, we change the symbol, the sign. Okay, this starts as x to the third. It goes 3, 2, 1, 0, so we're good. We don't need any placeholders. Our first coefficient is 1, 7, 2, negative 40. Every time I do one of these, I get nervous because I know this should be 0. If this is not 0, I did something wrong. Okay, so you could almost put that 0 in. If I've told you that's a factor or that that's a solution, this better be 0 or you did something wrong. Okay, bring down the 1. 2 times 1 is 2, 9. 2 times 9 is 18. That's where I start to get nervous. 18 plus 2 is 20. 20 times 2 is 40. Great. Whew, I did it correctly. I don't have to do it again. So now we have a depressed polynomial. We reduce the degree by 1 because we already factored out one of its factors. One of its factors, we already know, we did from here, is x minus 2. We depress the original by 1. So now what do we have? We have 1x squared, or just x squared. And I'm looking at these coefficients here. So 1x squared, that's what went here. Then I look at my 9. That's going to be on my x, so that's going to be plus 9x. Whoops, I don't know why that's skipping. Okay, and then the 20 is my constant. There we go. Now we have depressed. Now I could actually continue this and solve it if I wanted. The two other dimensions on this, we do have to find all three factors here. And so this is, if you don't know how to factor, you need to go to my YouTube channel and find my videos on factoring. I did 4 different videos. I found GCF, actually 5. I did the GCF, Magic X, I did box method, grouping method, and trash method. You can go to my YouTube video and you can find the one that you need so you can learn this material. Or find a different YouTube video. If I'm too boring, find a way to do this. So this would be x plus 5, and this would be x plus 4. Okay, so that's the 3 factors for this one. Let's do the final one real quick. I'm not going to take a long time on this last one. We're given 2x to the third minus 5x squared minus 28x plus 15. I tell you that one of its factors is x minus 5 and to find the other 2 factors. If that's a factor, we switch the sign to find the solution because that would be x minus 5 equals 0 for zero product property. Add 5 to both sides, so 5 goes in the box. Remember to look for anything placeholders. In this case, there isn't because we go 3, 2, 1, 0. So we just put our coefficients, 2, negative 5, negative 28, and 15. Now, if I do this correctly, the remainder should be 0. I told you x minus 5 is a factor, therefore that has to be true. Bring down the 2. I don't know why this does this. 5 times 2 is 10. Negative 5 and 10 is positive 5. 25 goes here. That gives me a negative 3. I'm feeling good. Negative 15 and 15 is 0. We've now depressed our polynomial because we already factored out one of its factors. So we took away one of the x's by doing x minus 5. That was one of the factors, leaving us with 2x squared plus 5x minus 3. Then again, you need to factor and get all 3 factors. So then you need to take the x squared and you need to factor it. And again, I'm not going to go through factoring with you. I have plenty of videos on that. If you don't know how to factor and the videos don't work, come see me and I will help you again. But I'm not going to put on this video and make it way too long. There's my 3 factors. I could find my 3 solution. I would know where this polynomial crosses the x-axis.